Okay.
Um,
I accidentally forgot to turn it on live, so we're finally live now.
oh,
Oops.
okay, good.
But now, okay, so two of us have
Maybe
been
that's
kicked
why I was
off.
able to join you.
Oh, that would
Wonder.
explain it.
You know
Okay.
what?
You know what? I'm going to just do it by hand, Lori, for just a second because I can't access the information for the.
Okay.
So I've got the papers printed out. So hold on one second while I do it
Okay.
on my calculator.
So we've been kicked off.
You know what, Abigail?
Susan. Yep.
I think that really makes a difference. Don't go live until we're all here.
Okay.
That
Yeah.
could really make a difference because I could never get on either, Susan, until they sent me the link.
Yeah. So thanks for sending that.
Yeah, so we'll remember to do that too.
All right. So.
All right, Susan, do you have it printed out and all your answers, or?
Yeah, I've got it printed out.
Okay. So let's
I'll just have to trust you guys. Ah.
So then the next question says, oh, true or false, I created a histogram representing the amount spent in the, okay, so now let's move on.
I've just lost my connection.
Yay, it's not just me.
Oh, no.
Wow.
My Safari won't even open.
That's so weird.
Oh, no.
Uh-oh. Ha! Okay, wait.
And it won't let me log in.
Yeah, it wouldn't let me either.
Oh, great.
Okay, do you have all the...
in!
Because I closed out of mine. Made room for you.
Well, I closed out of the window that had everything in it.
Uh-huh.
So I think that's what it is.
Okay.
Oh, it saved my answers. That's awesome.
Oh,
all right. Yes, that's the answer that I got again for whatever number we're on. What number are we on? Hold on. Now where did I put my papers?
1.96.
I got the 1.91.
Oh, wait, it didn't save all my answers. Okay, so 8's a cluster.
Wait a second, Abigail. Go ahead, Susan. Or I mean, Stephanie.
I got the 1.911. So the 9. So we're going to round it up to the 1.912. That's what I've got.
Okay, me too.
So Susan, is there something? Seems how you got a different answer. Is there something that we're missing, or?
No, it was for the one beforehand. It was number 9.
Okay.
Okay.
Sorry.
So for 9 we have 4.771. For 10 we have 1.912.
What about for 7? Because my answers didn't get saved for that.
Okay, 8 is stratified, 7 is simple, 6 is cluster, 5 is stratified, 4 is 100 is a parameter, and 112 is a statistic. 3 is the toothpaste.
Okay.
So now we're moving on to 12.
Mm-hmm.
Wait
a minute.
The questions on the quiz are not going directly with what's on.
Yeah, I'm like, wait a minute, that's not the answer I got. Okay.
So 11 on the quiz says I created a histogram representing the amount spent, true or false.
Right.
So now I'm on 12 for the quiz, and I believe 11 for the paper.
Right. Okay, so I got a negative 0.165.
Yes. My gosh, I love it when we match.
I know.
Thank you.
Did you guys get that as well?
Yes.
Negative 0.165, yeah. Because I made my histogram. I did it.
Yay.
While I was waiting to get everything back, I was just like, what the heck, I'm just going to finish this.
Okay, so 12 on the paper, 13 on the quiz. What is the value of B? And I have 0.681.
That's what I've got.
What would you say? You're muffled.
0.681.
Okay, good.
Does that work?
Mm-hmm.
Okay, now here's where, okay, so number 13 on the paper, 14 on the quiz. What you guys put for that?
I put the variance.
You did 2.
Yes.
3,
Variance.
24.
All right, guys, well, I want you guys to know I fired my tutor this morning.
Why?
I'm starting to know more than him, and
No!
it was becoming like I don't think that's right, and I think it's right. So I fired him this morning.
Well, good for you.
Night, and I let him go this morning. I just went, I can't do this anymore.
That's funny.
So he was dead. All right, what is the standard deviation of these temperatures?
I put 0.619.
Ah. I have 0.715.
Okay. So,
What do you have?
9.619.
Same.
Okay.
so let's go over it then, Lori, to see how.
Was that your
All right.
tutor's answer?
No, I did all my own work.
Are you on the Devo?
I do all my own
Okay.
work. Okay, so find the standard deviation.
Lori, you're muffled.
I'm sorry. Is that better?
Yes, that's better.
Okay, so you add up all the squared variances, right?
Yes, all the squared answers. So do you want to go through what the squared answers were, what you got?
Yeah.
Okay, so for Bodil, I got 0.027.
Yes.
Roberta, I got 0.681.
Yes.
Larry, I got 0.819.
Yes.
And Per, I got 0.007.
Okay.
So then my total came to 1.534
Okay, that's what I got.
divided by 4.
Well, now wait a second. This you got
have
to go divided
have
by n minus 1.
No, on my, let me read. On my steps, it says, add up all the results from the new values, which is the squared values, and divide by how many values you have. It's the same as step 1, which was, dividing by your values. Hold on, let me write that down. And then you square root that answer. And then that.
So I have in my steps that you have to take the sum of the square deviation and divide it by n, which is the number of fields, minus 1.
Okay.
And then you take the square root of that number.
Okay, so let me do that math and see what.
Okay, so I got this from lesson 3, the preparation note.
Okay. So if we take, all right. Can't find my calculator. Where did I put my calculator? All right, so you're saying you take 1.534 and divide it by n, which would be 4 minus 1?
Yeah.
Okay. Yeah, I see that in my notes now.
Do you?
Yeah, so I had just looked up online how to find the standard deviation, and that's how it said online to do it. So, but no, you know what? That's the sample variance, isn't it?
Correct. That's the sample variance. But in order to find the standard deviation, you have to first find the sample variance and then square root that. And then find the square root of the sample variance.
Divide the sum of this by n minus 1.
So for the sample variance, I had 0.55.
Okay, hold on one second. I got to find my calculator. I thought I had it up here, and I cannot find it. Oh, there it is.
I mean, oh no, I didn't get 0.55. Sorry, I'm looking at my lesson.
Yeah, you're looking at your notes. Yeah.
I got 0.5113.
Yeah. Okay, I get that. 0.5113333333, and then you square that.
Yeah, I mean that's what I did.
But then it is 0.261. Is that what you got?
I got 0.715. So you take the square root of 0.5113.
You take the square root or the square? Take the square root. Okay.
You take the square root of 0.511333333.
Okay, yeah, I see that.
And I got 0.715.
Okay.
Now listen. Susan and Abigail, I mean, chime in here, please, because
I can't find my calculator.
I went back to my preparation assignment, to lesson number 3.
Okay, let me look.
Where we did all of that.
And that's how we did it in lesson number 3 then?
It is.
Okay. Well, then I will agree with that. So let's do that. 0.715.
Yeah, but you guys.
Well,
I don't
Lori,
want
you're probably right, because I went on the internet to look because I couldn't figure out how to do it. And so on the internet it was different. So you're probably right.
Okay, so just so you know, you take the sum of the square deviations and divide it by n minus 1.
Yeah, I've got that in my notes. I was thinking that was for the, because I wrote on my notes next to the 0.55, I wrote this is the sample variance, and so that's why I was confused.
Okay.
So that's because I couldn't find where how we figured out standard deviation. So that was my.
Yeah, but Susan and Abigail, what do you guys think?
I agree with Lori. Like, I must have messed up my calculation somewhere.
I know, but if you guys all got the same answer and I got something different, I'm like, But I did go back to that preparation lesson. So, Susan, do you have anything to say about this one?
No. I was just trying to find my notes and my calculator to recheck it. And I'm not having any luck.
Okay, well, let's circle it and we can always come back to it again, too.
Okay.
Okay, so then the next one, the question is, what is the, oh, no. Oh, under certain conditions, the standard deviation can be negative.
That is false. It's never negative.
Okay, that's what I have as well. That one I did have to look up on the internet. I couldn't find that in my notes anywhere.
My husband explained it to me because when you square it, it can never, once you square even a negative number, it is always positive. Okay. So that's why. That's the reasoning.
Okay, that makes sense to me. Thank you.
Mm-hmm.
Okay.
How come I can remember it after you say it, but it's like,
I know. When you read
I've heard that before.
Okay. All right. So, number 18, are you guys back on the quiz now?
Yes.
Okay.
But I, 18 on the,
No, 17 on the
So 19 on the quiz. Wouldn't that be 8?
well, wait a minute. What about 17?
We're on 17 on the quiz. Which location resulted in the
Oh,
most
sorry.
consistent temperature measurements from one seal to another?
I put the extradural.
I did too. 0.577.
Mm-hmm.
Yep, I did too.
So that's the smallest standard deviation, right?
Yep, that's what I put.
Okay, 18, I can define standard deviation in my own words. True.
If I can read it.
I have how far the data is spread out from the mean.
Yeah.
Yes, that's what I put. The standard deviation is the measure of the spread in a distribution. So.
Oh, very nice.
I put it's the amount of space it takes up, but I guess that's the same thing.
Well, what I realized is you have to say somewhere in there from the mean because that's
Okay,
Oh.
right. Okay.
Yeah,
from the mean.
it's
Right.
going left or right from the median.
Right.
Okay.
Mhm.
Yeah.
Okay, perfect.
Okay, let's see. 19. Or 8, yeah, 19. What is the third quartile? I put 8.
Yeah,
From 8
it's
to
8.
12.
I put 8, let's see. Third quartile, I put 8, yes.
So 12. Susan, did you say that?
8 to
Yes,
12.
8.
She said 8 to 12.
Let me say 12 would be your maximum number.
8,
Right.
the quartiles go according to the lines.
Oh.
Okay.
So your first quartile is 4, and then your median is 6, and your third quartile is 8.
Right.
Okay.
Okay, and then what percentage of the data lies between 4 and 8? I put 50%.
Yep, that's what I put.
Yes.
Yep.
And
Okay.
don't include a percent sign, it says.
Correct. And that will mark it wrong if you do, because I've done that before. I had to fight to get my points back. Okay. Okay, now, oh my gosh, you guys. This was hard for me.
Okay, it was so hard for me. I could not get this. In fact, Lori, yesterday I was so tempted to call you. It was so funny because you had emailed, and I'm like, oh, I should have called her because I had struggled with this.
Yeah. Okay, so it says estimate the mean, and I just added 1.59 and 2.52 and divided by 2 and got 2.055.
Yes, that's what I did too. Yep.
I don't know if that's right.
I don't know if that's right either, but that's the only thing I could come up with, and my husband, that's the only thing he could come up with too. So he's like, that's what I.
So what'd you do?
I took 1.59 and 2.52 because that's the only data that we had, and divided it by 2 to find the mean. Now, my tutor didn't agree with that, and he did this whole thing with the mu minus 2 times the standard deviation. He did this whole thing that I never understood or have never seen before. So I came away from this totally confused.
Yeah.
Mhm.
I think, but I think that's what it is. I think it's that easy.
So he told me it was wrong, but
Yeah, because that's what we've noticed lately. We've been like, this is too easy, but it's still right. So.
yeah. Okay, so then what did you get for 21? Estimate the mean measured.
Oh, wait,
Sorry, that's the one we just did. Sorry.
Okay.
I did
estimate the standard deviation. So I got 0.2325.
Okay, I did not get that.
Okay, so now we need to go through it.
And now let me tell you what I did. I did that same thing that we did with the seals.
Okay.
Did you
And
do
see,
the
then
same
my
thing?
math is probably off. So
Well, no, so then I did that square root thing, the sum divided by n minus 1. Is that where we're off again?
yeah, that's where we're off again, I think, because I think you're right, Lori, because going back through my notes, I mean, like I say, I haven't written, I don't know why I wrote down that that's the sample variance, but I think that I think that's right. So let me hurry and do the math on that.
Okay,
And,
please.
Well,
and
what's the mean you got? Because you added those and it's 4.11, right?
well, no.
Okay, so I set up another chart where I took the observation, then I took the mean where I did 2.055 minus 1.59 and got negative 0.465. And then I squared that, and I got 0.216235.
Okay, hold on. I'm going to do the math for just a second. Hold on.
Because there's nothing in that problem that gives us any standard deviation. But the thing that throws me is when it says we will assume that 1.59 is the value of mu minus 2 times the standard deviation. That sentence in there, it's why I think I got it all wrong.
Wait, but they're just asking for the nitrate concentration in the water. They're not asking for...
Between here and here.
No, it says estimate the standard deviation of the measured nitrate concentration in Rexburg drinking water.
Okay, so...
And in the story problem, it's just telling you that the nitrate concentrations above 10 parts per millimeter are considered a health risk. That's not the standard deviation.
All right, sorry.
I mean, you know what I'm saying? Don't
Yeah.
think like they argue with me.
The problem again.
You guys argue with me because I really struggle with these.
Okay, let me see if I can explain this, okay, so I know you guys probably can't see that, but I made the chart,
Okay.
you know, so it's the 68, 95, 99.7 rule thing.
Yeah.
Right.
Okay, so it's 2 standard deviations. So
Right.
we know that one side of of the chart is going to be 1.59 is the minimum.
Right.
The 2 standard deviations away from the mean, which we
Right.
we all agreed on that it was 2.055, right?
Right.
Yes.
Okay, so the mean is in the middle at 2.055. One side, 2 standard deviations away is 1.59. 2 standard deviations away on the other side is 2.52. So we know that it's going to have to be equal between all of those, right?
Yes.
Does that make sense?
Yes.
Okay, so then you said that it was, what did we say, 0.465 for the 2 in between?
2.05 minus 1.5.
So
Yeah.
2.005 minus 1.59 comes to 0.465.
Okay.
Does that make sense? But now we have to divide 0.465 by 2 because we have 2 standard deviations, or 2 whatever standard deviations away. Does that make sense?
Yes.
So we get 0.93.
Well, do we add them or do we square them?
No, okay, hold on. Hold on.
Yeah, because when you divide 4.465, you get 2.2325.
Okay, yeah, that's right. That's where it is. So yeah, so that's where I got that answer, is dividing that. So
round to
2.2.
3 places be 233.
Oh, yeah. 233.
Rounded.
Rounded. Okay, so does that make sense? Or not really?
It does, but is that consistent with stuff that we've learned? Do you
No.
understand what I'm saying? Is that consistent with how we've been taught to estimate the standard deviation?
Right, I know.
But that's what I'm questioning too, is why did they put that in there?
I don't know.
Because you could have figured out the standard deviation without them putting in there that 1.59 is the value of mu minus 2 times the standard deviation.
Right. I struggled with this one, so this is what I came up with, and like I say, I don't know that it's right, but I don't.
It makes sense to me, but we never learned to do it that way.
I know. I know. Yeah.
Okay.
I know. I think that's the biggest problem I have with this class is I feel like there's so many things that we aren't really learning. So I don't know what to tell you guys. Lori, what did you come up with and how did you come up with it?
Okay, so again, just like those seals, the table that we just finished with the seals,
Okay.
I made another table like that
Okay.
because it was consistent with the
With
way
that.
we're learning. So then, but what you did kind of verifies that 2.055 has to be the mean. So that's good. So maybe we answered that correctly.
Yeah.
So what I did is I set up that table. I listed my observations, 1.59, 2.52. You probably can't see this. It's too small.
Yeah.
See right here? And then I just
Okay.
did my value minus the mean, which is 1.59 minus 2.055, and I got a negative 0.465, which is the same as you.
Okay, yeah. Yeah.
And then I went to the next column in that table, and I squared that, and I got 0.216.
Okay.
Which is
So you squared 0.465. Okay, yeah, 0.216. Okay.
And that makes it positive.
Yeah.
Because if you were to just divide negative 0.465 in half, you would still have a negative number, right?
Yes.
Yes.
Mm-hmm.
Which is why you have to square it
Right.
to get rid of that negative number. Okay, and so then I added the sums of those two things because 2.52 minus 2.055 is a positive point. Okay, wait a second. I think I made a calculation error. Hold on. 2.52 minus 2.055 equals. So I made a calculation error in my stuff. So, oh no, I didn't. I'm okay. Because then when I squared it, I corrected it. So then I got the same square again because 2.52 minus 2.055 is 0.465, right?
Right.
And then you square that, and you get, again, 0.216225. And then you add those together, so 0.216 plus 0.216 equals 0.432. And then you divide that sum by n minus 1,
Okay.
which is 1. And so I got 0.43245, and then I took the square root of that. So I did the exact same thing that we did with the seals.
Right. Okay.
So my answer, the square root of 0.43245 is 0.657, or rounded is 0.658.
Okay.
This is why I emailed you yesterday.
Yeah, I can see.
I don't know.
All right, well, let's go down to 23 and see what numbers if they plug in. Does that make sense?
Okay, so number 23 didn't have anything to do with.
No, it's not on our thing.
Guys, question 24 and 25. Question 23 on our paper is question 24 and 25. But
Okay.
I'm looking at question 23, and it says, between what two measured nitrate concentrates do approximately 68% of the data value lie? Those were not the answers I got. I didn't get any of those answers.
68%. That's the first, that's one standard deviation away, right?
Right.
And our mean is 2.055. So then we have to take our standard deviation and plug it in. So we go 2.055 plus our standard deviation or minus our standard deviation to find out what that 68% is, correct?
Yes.
Yes.
Okay.
And we do it to both of those numbers.
Yes.
So we still have to just.
So let's plug in your numbers, Lori, and see if that works.
Okay.
So
So you're taking 1.59 and you're adding 0.658. And I get 2.248.
so that can't be right then.
No. Wait a minute. I have to go. Do I have to go a negative 1.59?
Well, no, we work from the mean, right? We take from the mean, we go out to the standard deviation. So if we're going to go 2.055 and then find the next one. So if we're going to go positive, then we would go plus, what did you say?
I got 1.397. Okay, so this is what I did. I took 2.055, which is our mean, minus 0.65. Okay, so I get 1.3 minus 7 for one of them, which isn't even. There's a 1.357. And then I have to take 2.055 and add 657. And I get a 2.7126.
Okay, so that's not going to work because that's only one standard deviation, but our two standard deviations is 2.52, right?
Okay. Oh my gosh.
Okay, I'm going to try it with the number I got and just see if that works.
Yeah, see what you get.
Okay, 20, or no. Okay, so for my one standard deviation, I got on the positive side is 2.29.
Okay.
And then I'm going to add one more and see if that adds up. So
2.288.
and that's I did get that. I did get our answer, the 2.52 for the second standard deviation.
That's your answer.
What?
So with one standard deviation for the question with 68%, Did you get 2.288?
Yeah, and I rounded up to 2.29.
Well, go three.
Oh, yeah. Okay. Yeah, see, I'm so bad about that. Okay.
So what was 22?
Now
Okay,
go
so
to the other
hold on. Let me subtract and see what we
Yeah.
get for the next one.
Okay.
one. Because that's an answer on there.
Okay, yeah. Okay, so for the next one, I got 1.8225. So 1.823 or 22. Okay. All right. So what do you think?
Well, I think we go with your answer.
Okay. I'm sorry if we're wrong. I'm sorry.
Okay, so now just tell me again. So the two standard deviations was 0.465, correct?
Hold on. Yes, the two standard
And you
0.4,
divided it in two.
and I divided it in two. Uh-huh.
0.233.
Yeah, 0.233. Yes.
And that's what you put as the estimate the standard deviation.
That's what I put. Yes.
For 22?
Yes. And I'm sorry if I'm wrong, but that's the way I figured it out.
And then
I
you
think
have
you're right.
1.822 and 2.288.
Yes, that's what I put for 23. Yes.
Okay.
So, okay. One more time.
Okay, so you want me to go through how I figured it out?
Just 22 and 23 to make sure I did my calcs
Oh,
right.
okay. So I've got, for 22, I put 0.233.
Okay.
And then 23, I put 1.822 and 2.288.
Okay.
And I'm really sorry. If
So
it's
I'm
not-
It's okay.
You're right. If you were to put those numbers on your picture of your graph,
It worked.
that's what. Oh, you can't see. I've been adding mine to the picture, and that's where the numbers would be.
Yeah. And it's got and that's why I said I've never seen that mu minus 2 times the standard deviation. I've never seen a question posed like this. So it's
Me either. I spent hours yesterday going through my notes and going through everything, and I was like beyond crazy yesterday.
But this was such an easy. So maybe when it says estimate. Well, no, I'm not even going to go there. Okay, this works. Let's leave that alone. What is the value of the mean of a standard normal distribution? Put 0.
Yes.
What is the value? Is that right?
That's what I put.
What is the value of the standard deviation of a standard normal distribution?
I put 1.
Put 1. Susan, Abigail, what do you think?
I agree.
For 1?
This is for question 24 and 25 on the quiz.
Yeah, so 25 is 1?
Yes.
Okay. And 24 was 2?
0.
0. I knew that. Sorry.
Okay.
Gosh.
Let's move on. Oh my gosh, I'm so confused. Okay, so 26,
Okay.
which is actually question what?
Okay, what is the probability that a randomly selected student, I put 50%.
I did too. So when I did, I'm trying to think how I did the z-score equals x minus mu divided by the, no, how did I do that? How did I get 50%?
Well, I didn't do any formula. I just figured that if the mean is 54 or 542.3, then that's smack dab in the middle. And if
Yeah.
okay,
Yeah.
okay,
That's how I got it. I'm sitting there going,
okay. But it says round to the nearest tenth. Do we just put 50?
well, you put 0.5.
Oh, okay, 0.5. That's right. 0.5. Okay.
right?
I'm like, that confused me. I'm like, what?
0.5 is 50%.
Yep,
right?
got it. See, my brain is fried.
Okay, you kind of threw me there. That's now see how weird that they asked that. Because it's a probability, that's why you have to round it. It's not a percent.
Right. Oh, right. Okay.
Because they're not asking for a percent, they're asking for the probability.
Yes, you're right.
But 542.3 is the mean. So, okay. Question 27. What is the probability that a randomly selected student will score below 600?
And I put 0.684.
Yes, that's what I got too.
Yay.
Are we good on that one, Susan?
Yep.
Yep.
Okay. All right. 28. What is the probability that a randomly selected student will score 600 or above?
I put 0.316.
Yes. And did you get that by subtracting 0.684 from 1?
Oh, no, I did that from the normal probability app. So,
Okay, but remember, that's where we screwed up before on another one of our homework or group quizzes, is we didn't subtract it from 1.
okay, so let me write that down. So we're subtracting 0.684 from 1.
Right, because see, it used the same, it was either above 600 or below 600, and it has to equal 1.
Oh, right. Okay. Good. Thank you for saying that, because I wasn't sure how I got that. I mean, other than I...
Well, but I'm just saying, that's what we learned is that minus 1. Anyway, okay, I'll shut up now.
No, thank you, Lori. Thank you.
Okay, so now we're on to...
Find the GMAT that corresponds with the 10th percentile.
Okay. Okay, I got 527.112.
Okay, I did not get that.
Shoot. This 10% stuff kills me. What did you get, Susan?
I didn't.
Did you
Okay,
get it?
But that 500 seems high.
I thought so too.
Okay, so I got 387.8, but it says we're supposed to round to the nearest whole number, so would that make it 388?
Yeah, that seems more reasonable.
Yeah.
Okay, so let me tell you how I got that, Lori. Okay, I found the z-score, and then, let's see, I'm trying to figure out my notes here. I got the z-score, which was negative 1.282, and then we're looking for x, right? Because we want to know what the 10th percentile score was.
Well, yeah, you know what? I used the wrong z-score thing. I used the simplified z-score formula, not the divided standard deviation divided by.
Okay.
But we don't have n. Okay.
Let me see.
Tell me your formula. Just read your formula to me.
Okay, well, I'm trying to find my formula for how I figured out the z-score, because I just wrote the z-score out to the side. So let me see where, let me look at my scratch papers. Hold on.
When I got that 10%, I thought, gosh, that is so high for a test score that you're in the 10th percentile.
Right. I have so many scratch papers now I can't even think straight.
I have learned to do everything right on my test and attach a paper and number the problems.
Okay, that's a much better idea.
It just helps.
Okay, let me rework it then, and so I can tell you how I got this, because I can't find that paper. So hold on. What did I do? All right, I'm going to work this. I'll be right back.
Okay, and let me now see. The way that you find, I mean, you have to have an n value in order to go the square deviation divided by n squared.
Right.
So what's your n value?
I don't know. Hold on. Let me. Yeah, I know.
So you got a z-score, 13%.
You could just invite your husband to join us.
Yeah. Brad, you want to come join us?
Should we have a drum roll? Is he going to come in?
As soon as I figure out how I did this, then because he didn't help me on this one. I can't remember how I did this.
Okay, you know what? Okay. So what I did was I went to the applet.
Yeah.
Put in 10%, and that.
You know what? That's what I did. Yes.
Right?
Yay!
Okay. Okay, so I went to the applet, and I got to pull that applet again.
Okay, so let me see. Okay, yeah. Oh, hey, if I would read my notes that are on here, it says put in applet and put 0.10.10. Shading. Let's see. No, that didn't work. Let's see.
Okay, so you got a z-score of 1.645, right?
Yeah, but that's not what, so I must have done something wrong then, because that's the z-score that it says, but that's not what I wrote down, and I'm not sure where I got this.
That's not what I wrote down either. I had 0.126.
Okay, there it is. Okay, you know what? That applet is so sensitive. Okay, so shade in just the left side. Well, let's see, yeah, shade in just the left side first, and then go up to the area and put 0.10, and then that's the z-score. 0.1 or 1.282. Is that what you guys get?
Yes.
Okay, so that's how I got the z-score.
So when you fill in both sections, it gives you a different z-score.
Yes, it does. But we're looking, remember in our...
You're on the left-hand side because you're just 10%.
Yes.
Right.
Yes.
Okay. Oh my gosh, you're saving us. Okay, so the z-score was negative 1.282.
Correct.
And then you solved for x,
Then
right?
we're solving for x, yes.
Okay, and so you just, oh my gosh.
So I did x minus 542.3 over 120.54.
Okay,
Then you do your algebra where you times. Okay.
Right.
Yeah.
So then it was minus 154.53228.
Yes.
Right?
Yes.
Plus 542.3.
Yes.
You got 387.768.
Yes. So I rounded it to 387.77, but I guess we have to do it to a whole number. Is that what it says?
What does it say, whole number? I'm going back in there now. That is the nearest whole number, so it would be 388,
Yeah.
right?
That's what I would guess, right?
So that's the app. So the applet thing is I have to be careful. You have to be careful what side you're putting the
Yes.
score in.
In my notes, let me grab my notes back real quick. In my notes, I put, let me find my notes on the applet. Because I was so confused with that I knew I had to write myself a note to make sure that I was doing it the right way. Okay, so if it's less than 50%, then you click on the areas that are, that you want shaded on the left side. And then if you want to find something greater than the 50th percentiles, you click on the areas with on the right side. But sometimes, and I can't remember exactly when, sometimes you have to do the middle and the middle too.
Right. And I get that. Okay.
Okay.
So for the 90th percentile again, you found what was your z-score?
Well, because the 90th and the 10th percentile are the exact same. It's
Right.
just going to be the positive of the 1.282.
So then you did 542.3 plus 154.53228.
Yes.
Right?
Yes.
And you got 696 or
Yes.
697?
0.83.
Yeah, 697 rounded up.
Yep.
Oh my God. This is why I called you yesterday. So it's 697, correct?
Yes, that's what I've got.
Okay.
Do you guys agree with that? I hope
It's
I'm not leading you
676.
astray.
I
It's
do,
676.
I redid the math, so
Okay.
I agree with you on that. Now let me ask you this. What does, just out of curiosity, 388 plus 697 equal 1,085? All right, well, that doesn't work. I was seeing if it equaled 1. But,
Oh.
okay, so find the first quartile.
Okay, well, I think I missed something.
So that's just the 25%, right?
Mhm. Yep. That's how I did it.
Yeah, that's how I did it too. And again, we are still below just the left bar, correct?
Yes.
And so you got negative 0.674.
Yes, that's what I got.
I'm just gonna check now just so I don't. It's minus 0.67.
Yeah. Went snorkeling and frisbee boarding yeah.
So, Abigail, did you say that you had?
Yeah, I think I missed 30 because my answer just wasn't adding up.
So I got 696.8. So I went ahead and just rounded it up to 697 because it says to round to the whole number.
Okay, so
So I was getting 532.
Pardon?
I kept getting 532, so I'm doing something wrong.
Okay. Do you want? Did you have your z-score of 1.282?
Oh, that's why. My z-score is wrong.
Okay.
I messed up on that. Okay. So it's 6.
I put 697, rounded it up.
Okay. So 698. Okay.
Well, put it as 697.
Okay.
Because
Okay.
it's 696.8, so I just rounded it up to 697.
Okay. Because that's why I looked like totally not involved in the conversation because I was like, this is not working. Okay. I'll go back and I'll look and see why I did that wrong.
Okay.
Okay, so Stephanie, did you get 461 for your answer?
I did. I got 461.1, but we would just round it to 461.
Okay, and then again,
And then the third quartile is the 75th percentile, so
So that's the positive number of that last one.
yes.
624.
Yeah, I got 623.5, so we would round it up to 624.
Oh my gosh, thank you so much.
Okay, but I'm hoping now you guys make me nervous because now I'm like, oh my goodness, what if I've done this all wrong?
No, these scores make more sense. Remember your husband always says, does it make sense? I keep saying,
Yeah, I know. Well, he heard lots of wailing and gnashing of teeth yesterday, so I was like, I hate this class, I hate it.
I was doing the same thing.
You guys have amazed me how well you've done.
I'm
very,
very
very
nervous
impressed.
for this test. Very, 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 very nervous.
Okay, so 29 you have 388.
Yes,
30 you have 697.
correct.
31 you have 461.
Yes,
32 you have 624.
yes.
Oh my gosh, thank you so much. I totally filled in too much of that applet. Okay.
Yeah,
So-
the applet gets me every time, and that's why I like having the answers, because then I can go back and learn and
Yeah.
Okay, so now we consider a simple random sample of 15 students. I gotta find out where I am. Okay, gosh, I hope I got some of these right. Okay, I got 31.123.
yes, that's what I got.
People, Abigail, what did you get for that one? Well, it says round to the nearest 10.
Yeah, so 31.1.
Yeah.
Is that what that means?
Yeah.
Well, it's all less than 5, so shouldn't it be 0?
They're not asking for the probability, they're asking for what the mean is.
Yeah.
How's that going? You like doing that
I'm
stuff?
good.
Okay, what is the standard is this the one that we're on, number 34? What is the standard deviation of the distribution of sample mean scores?
Yeah, you know what, sorry, that was number 32. No.
32 is 31.1?
Okay. What is the mean of the distribution of sample mean scores for all such? Isn't that the 542.3?
Yeah, that's what I put. The mean is 542.3 because the mean is always the same. The standard deviation is different, but the mean is always the same.
Yeah.
Okay, so then the way you, okay, sorry, I filled out the wrong question here on my quiz.
Okay, hang on. So,
Number 30.
what was 32 then? Because I have 33 right, but I'm lost on 32 because there were different numbers going around.
Okay, 32, I have 624. Is that what everybody
Okay.
else has?
That's what I have. So,
Okay. And 33, I have 31.1. Is that right?
No. That's where I just messed up. 33 is asking for the mean. It should be
Oh, okay.
so that's 542.3?
right.
Yeah, I think you're right. Let me, okay. Consider a simple random sample in the GMAT. What is the mean of the distribution of sample mean scores for all such samples? Yes, that is the mean. Yes.
The standard deviation, this is what we talked about on the
This
left.
is the 31 point, yes.
Is the standard deviation divided by the square root of n, right?
Yes,
You got 31.123.
correct. And we have to round that to 3 decimal places. So,
Yeah.
yes. Okay.
So the question to 34, the answer to 34 is 31.123.
Yes.
Okay.
Susan, are you good with that? Did we lose Susan?
Oh, no.
Oh, yes, Susan left the call. Darn it.
Okay. Okay, and then 32 is,
You mean 35?
yeah, sorry, it's 32 on the paper.
Yeah.
What is the probability that the sample mean is greater than 600? So I got 0.0319.
Okay, and I rounded it up to 0.032. Yes.
Okay. Because now, now I'm not trusting myself on that tablet thing.
I know. It's hard. Okay.
Just looking through to make sure we hit everything.
Yeah.
So Stephanie, you rocked this assignment. Now
Oh, well, we owe my husband because he had to deal through many tears yesterday and a lot of screaming.
I'm glad I'm not the only one crying. This is fun. I'm just like, oh my God.
But I hope that it's right. I mean, Brian's telling me it's right, it's right, it's right. So I'm hoping that it's right.
Okay, so now this means about when you guys trusted me up top.
Lori, you're really muffled. I'm sorry, I can't understand you.
Okay, so this is making me nervous now. When you guys trusted me up on top with that sum divided by n minus 1.
I think that's probably right. Because, I mean, you're right that it was, that's how it is in our, lesson manual, and I went looking on the internet. Let me just ask Brian really quick, because he was doing those with me, and he did get a different answer than me, but I was insistent.
Okay.
Brian, do you remember yesterday when you were doing it on Excel and I was doing it on the paper, and you got a different answer on Excel, right? You don't remember what the answers were? He got 0.719. Is that what you got, Lori?
Where is it?
If you just do scan STD for the formula,
Mm-hmm.
and that does it on a sample. They add the PN on the formula to get the population sample.
I got 0.715.
He got, okay, she got 0.715.
If they did it on Excel, they use more numbers.
Excel, yeah.
Make sure she uses the right formula.
But-
DED.
Okay, Lori, did you do yours on Excel, or you just did it by hand, right?
I did it by hand because
Yeah, she did it by hand and I did it by hand, but we got different ways. We did it different ways, and I got a different.
715 was based on the sample.
All right, let's read the question again really quick. Bri, do you want to come here and see this? If this is, what number is that? Do you remember, Lori?
it is the number after you added up all the square deviations and got the sum. I
Okay.
took 1.534 divided by n, which is 4 minus 1. And I
Brian,
got
his collar's right here.
0.5113. And then I took the square root of 0.5113.
Okay, hold on. I'm trying to find my paper. Where did I put it? All right. Okay, so Brian, what she is saying is that we, okay, so Lori, we get down to the 1.534 and divide it by 4, right?
No.
No.
But
You said don't.
we divide it by n minus 1, which is
Oh, yes.
4 minus 1.
Okay, Brian says that's the sample. Let me see. What's the question?
The question is, what is the standard deviation of these temperatures? So we're looking for the standard deviation.
All right, let me read over my notes again really quick here. Let's see.
So scroll down. That's one right there.
Okay, is it number 15 on the quiz? What is the standard deviation for these temperatures, of these temperatures?
Yes. Yes.
Yeah, that's gonna be that.
That is.
But
Okay.
when I put it in Excel.
It's going to be different because Excel uses all your extended numbers. You know what I'm saying?
Right.
So that can tweak.
I know.
I'm not saying he's wrong. Oh my gosh. Hello.
No, no, no. Oh, no. He's not taking that as that. No.
But what I think we have to realize is is that right when you take the sum divided by n minus 1? That's what I'm most concerned about is, do I have the right formula there?
Right.
And when you did it, so is this on a population or is this on a sample?
This is on our sample, right? Is this on our sample?
Or is it
Or is this on our population?
Well, it's on this. You're getting the standard deviation for those 4 seals. So it's probably the sample.
So it's probably the sample. Okay.
and that's going to be
I don't mean to yell, but you guys have had a hard time hearing me.
Oh, no, you're fine. And I probably yell too. I'm sorry if I'm hurting everybody's ears. Okay. Yeah, I'm honestly, I'm not sure on this then. I really don't know. Let me see.
I have. So when we totaled up all of the square deviations in column 3, we called that the variance, correct?
Yes.
Okay, because that's what we put for our answer.
Yes, that's right.
Okay. Then we get the sample variance, which is the sum divided by n minus 1. That's called the sample variance.
Yeah.
And then the standard deviation, we take the square root of that sample variance.
Of that number.
Yeah. So I'm
Okay.
just going to redo my math here.
Yeah, I'll redo mine too.
So for the sample variance, but see, I'm doing different math than you. You're just dividing by 4. I'm dividing by n minus 1.
I know. That's the thing. We got to just figure out if that.
I mean, because that changes everything.
It does.
Obviously.
So 1.534 divided by 3. Okay, so, and that's where, so 1.534 divided by 3 is the 0.5111333, and then you're square rooting it?
Yeah, then you take the square root of that.
And that's when you get the 0.715.
Yeah, I get 0.7150759.
Yeah, okay. And I get 0.715075754, so.
Right. So, okay, so then if you do it your way, then you just divide it by 3, correct? Or
no, you divide it by 4 because you have the 4 samples.
0.3835, right?
Yes.
And then did you take the square root of that?
And then you take the square root, which is 0.619273768. So yeah, I don't, but see, I found that online. When I Googled, how do I find standard deviation? And that's what it came up with. So, but we didn't learn that. So I would guess that you're right because we didn't learn that.
Well, the question comes, are you doing a sample or a population? That's the only difference you're looking at right now.
So Brian says the difference is between the sample and the population. So it's a sample, right?
And he said 0.719.
Yeah.
And I'm saying 0.715.
Yeah. So it's like he said, that's basically the same thing.
That's just
but we're just, but what he's saying is there's a difference, and I must be on the different. So I think you're right, because this is a sample population.
Okay.
Are you taking the values and extrapolating it to the whole population?
He says, are we taking the values and extrapolating it to the whole population?
I don't know.
I know.
The question is,
See, math brains and not mine.
you should normally calculate the population standard deviation if you have the entire population, or you have a sample of a larger population, but you are only interested in the sample and do not wish to generalize your findings to this population.
Can you hear him?
Yeah.
Okay. So,
Okay,
so I
well,
would.
gotta go.
Oh,
but-
okay.
All
I
right.
would say, Lori, you're right. So, are you okay with that too, Abigail?
Yep.
So, I think you're right, Lori. I was wrong. I shouldn't go looking on the internet for my answers.
No, because I think you're right about all these other answers today, Stephanie.
Okay.